about 6 months. So I.
So are you, do you see the presentation now?
So this is the entire course, right? These are the topics you're gonna
Okay.
discuss.
So there is no problem with the presentation. You see it very well, right? So
Sorry, I didn't get you.
you are watching the presentation right now. Okay.
Yeah, yeah, okay.
Okay. So let's start with um, the overview of the course. We will start with the first lecture today. The first lecture includes an introduction. We will discuss in a general way the roles of HVAC engineer in construction design and technical office phase. As a conclusion to what the HVAC engineer do and what the HVAC has to know to do his job in a good way. Actually, we will take in this lecture this introduction in addition to some basics of HVAC systems. These basics we will discuss how we can provide cooling to spaces. You there in case A, it's very hot in summer, so everyone is talking about how to. If you ask anyone about the method of the direction of heating, it will be from high temperature to low temperature. So if you have a cold ice cup next to it, a hot cup tea, the hot cup tea heats the ice, right?
Sorry, you see, the voice it's not clear. So some of the things I can't get you.
Okay, do you hear me now?
Yeah, I do, but the voice, it's now it's
Okay,
fine, I guess.
I am telling you, is this okay right now? Okay.
Yeah, okay.
If you have any questions, if you have any thing you need to add to the presentation, you have to tell me. You shouldn't be ashamed of anything, okay? If
Yes,
there's
okay.
any problem with the voice, any problem with the explanation, you need more elaboration of anything, you ask immediately, okay, Nicola?
Okay, okay.
Okay. So I'm telling you about how the split unit in your home, how it provide cooling, how the idea of AC wall. This will be the topic, the second part of the presentation today.
Okay,
So let's begin with the introduction.
okay.
Uh, since you are a great contractor, so you know that any project has an owner. The owner under the owner there is a team of project managers. The project
Mhm.
managers manages the consultants and the main contractor. And the main contractors has to deal with many subcontractors, many suppliers, many technical ops engineers. You know this
Mm.
very well, right?
Yeah, yeah, yeah.
Okay, so the role of the owner, we have to summarize the role of the owner. The owner role is to appoint the project manager and the consultants, to pay for the work, to provide the site, to give the possession of the site to the contractor, to give instructions, approvals, and everything like that. Moreover, the owner has to provide any materials required to be provided to the employee.
Yeah, okay.
So, from your experience, what is the difference between the consultant and the contractor from your field of expertise? What is the main difference?
What is, sorry, the question was?
What is the main difference between the consultant and the contractor?
Me, my position or something?
No, in general, from your experience.
What is yeah? Well, I guess consultant, right?
What is the difference between them? What is the role of the consultant and what is the role of the contractor?
You see, the consultant will consult with every matter, and the main contractor will execute the project.
Okay, so we have to agree about the point that you have just said. The consultant is designing the project,
Yeah,
while the contractor is implementing the project.
yeah,
So they are completing each other.
yeah.
So to summarize the role of the consultant could be a single person, could be an entity, but the main role is design and the construction supervision or project management.
Mm.
The consultant may design all parts of the work or may design simple parts of the work. He gives approvals and certified payments at the end of the project. He makes the variation orders and verifies that the contractor is not taking a lot of money, right?
Yeah.
Okay. So consultants are the evil side of the industry or the contractor.
Sorry.
The consultant or the contractor, which is the evil side of the industry.
It's the contractor.
Yeah,
Yeah, because they're the one execute the.
the lowest quality ever, right? To
Yeah,
make maximum profit.
yeah.
Okay, so let's discuss the role of the contractor. The contractor they complete the roles in the contract. He is designing specific parts of the works like we will see in our course.
Mm.
He provides performance security.
Security,
Moreover,
advanced payment security is required.
yes, he comply with the instructions of the project manager.
Yeah,
He provides he provides all notice that is required by the contract
yeah,
to avoid additional payment.
yeah.
Okay, so there is no relation in the industry between the consultant and suppliers because this will be
Contractual relationship. Okay. Consultant and contractors.
yes.
So contractors and consultant, they don't share a contractual relationship. Okay, I understand that. Okay. So
Uh,
the contractor basically deals with the project manager, right?
yes, the contractor has to deal with the project manager. He is the manager of the site construction works. To simplify his role, he collects all the information from the drawings provided from the consultant and begin to execute them in the project,
Okay.
which is a very tough process because designing, as we will see in the course, we will study the design, but implementing this design can be implemented in many ways. It can be implemented with millions of materials. It can be implemented with different suppliers, different operating strategy. So it doesn't end about in the design phase, but the contractor has a huge role.
Yeah, because you see, the contractor is the one who is executing everything. So the main part, you say the bulk amount of work, he's the one doing the bulk amount of work.
Yes,
So yeah, he got the main contractor or the subcontractor. Both of them has a very important role to play in any kind of project.
yes, yes. He is also evaluating the suppliers. He should obtain the minimum price and the maximum quality for the project based on the client requirements. This is a very tough project. He is also he should be able of defending the execution of his works against the consultant when he the consultant who is supervising about the whole project. So he should be aware of the code. What does the code say in the installation of ducts, in the installation of pipes, in the installation of air conditioning systems?
Yeah.
So he should be aware of the whole code.
Yeah.
Okay. So next slide we will talk about the project management. So every team, architecture, structure, mechanical, and electrical, every team has design, production phase, while the mechanical and the electrical team, which is called an MAP engineer, mechanical, electrical, and power. Mainly we will study in this course is the HVAC and the mechanical part.
Yeah.
So the owner can be a design reviewer, can be a procurement engineer, can be a facility management engineer. And I think you from your expertise is meeting with several owners, right?
Yeah.
Okay. The consultant is designing the project. He will be in the technical office for any quotations and review of any submittals. Moreover, he will be supervising the construction works after the contractor finish. The contractor, we spoke about the role of the contractor. Last one is the supplier. The supplier, we have technical sales and sales engineer, the people who has deep knowledge in one specific part of the industry. He's trying to sell you a heat exchanger, a chiller, DX unit. He's the one who has a product, and the contractor is the one who has the money to buy this product. So are we clear now, or you have any questions?
No, the roles I am familiar with.
Okay. What is the construction stages of any project? It begins it begins from the feasibility study. The
Yeah.
feasibility study is followed by the design. The design is done by the designer of the HVAC system. Then the project will be in the tender or bidding phase, where contractors submit their offers.
Yeah.
Which contractor will execute the design works with the minimum price and the maximum benefit. So this is the tendering or bidding phase.
Yeah.
In this phase, we will the owner and the designer revise the technical and the financial offers submitted from each contractor. Then after that, the process go to the pre-construction and long lead items. Then execution begins. Execution is the sole responsibility of the contractor. After that, and after the project is executed, consultant and the contractor participate in testing and commissioning of all installed equipment.
Yeah.
At then, and everything is okay, we have finished the execution, we have finished the testing, we have finished commission. The owner open the building, and the people, whatever office building, educational building, hospital, and people start to use the building. During the building use, a new role appears, who is the facility manager. Do you know what the facility manager do?
Facility manager?
Yes.
I don't know actually.
Okay, facility manager is the person who is responsible for operating and maintenance all of the equipment inside the building after occupancy.
Oh, okay.
So we have perfectly designed HVAC system. We have perfectly constructed the HVAC system with materials of the highest quality. But if you have a poor facility manager, he will operate. He will operate everything in an inefficient way. What do you mean by an efficient way? If we have the cooling load of the building on 3 chillers, do you know what is a chiller, right?
Sorry?
Do you know what to mean by chiller?
Chiller?
Yes.
Yeah, chiller I know.
Okay. If the design has 3 chillers and the contractor installed the 3 chillers.
Yeah, okay.
So the facility manager who is the person who tells at the time of part load which chiller we can operate. And do we have to operate all the 3 chillers, or we can operate only 1 chiller in this phase? And if we can operate a single chiller, this chiller will operate at its best efficiency point or not? These are all questions that should be answered by the facility manager.
Okay, okay.
He also delivers a maintenance plan because every equipment needs maintenance, right? As you know, right?
Sorry, I didn't get you.
Do you know maintenance of equipment?
No.
Okay, every equipment through its lifetime, it has to it has to undergo maintenance. Like your car, when you go every month to change the oil, you go every 1 year to change the battery, right?
Yeah.
So every equipment needs maintenance. Maintenance is the process of maintaining the equipment at the installed state, so it can run for a lifetime.
Yeah.
So maintenance of equipment is the responsibility of the facility manager. So the facility manager is the person responsible of operating the equipment in a proper way and maintain the equipment at their current state by providing a maintenance schedule. Do you have any questions?
This one, no. You see, my main focus is to know how the chiller works or how the entire HVAC system works, you know.
Okay, I know this is a sample introduction, and we will go through the refrigeration cycle, and you will get painted by the details of the HVAC system. It's just a quick review to be aligned on the same vision. You see? Hello?
Yes, yes, I understand.
So I will try to make it faster. The design stages, we have several design stages. Concept design, then schematic design, then design development, and the tender design. Okay?
Okay. Basic design.
Do you hear me?
Yes, yes, yes.
Okay. So concept report includes codes and standards, value for the design input data, outdoor temperatures, occupancy, lighting loads, fresh air, exhaust flow rates, design conditions, and we will see now what is the importance of each one of them. Air conditioning systems and the description, whether you will use a chiller, like you said, whether we will use air handling unit, whether we will use control unit. Okay, This is
Okay,
the-
system vision.
Yes.
Okay.
We determine system capacity and comparison if we need in the concept report. We provide riser diagrams like we will learn to do. We provide zoning, we provide parking inflation and solutions for the project. This is the concept design phase. In the schematic design phase, we try to provide space requirements, where to put the chiller plant, where to put my shops and staff openings, where we can find mechanical areas for HVAC equipment, and how to provide single line HVAC plans, including all equipment.
Okay, single line plans including, yeah.
Okay?
Hmm.
Next phase is the design development phase. The design development phase, we will use double line plans, which shows the duct with its dimensions, with the pipes with its dimensions. We will know what meant by duct, what meant by pipe in this session, inshallah. We will deliver equipment schedules, bill of quantities, and specifications. At last is the tender design, which is the complete package that is issued to the contractor for implementing. It includes many details, further diagram, bill of quantities, and specification.
Okay.
Okay, as you see, HVAC stands for heating, ventilation, and air conditioning, while MEP, like you said, mechanical, electrical, and plumbing. The main standard in HVAC is ASHRAE. ASHRAE stands for American Society of Heating, Refrigeration, and Air Conditioning Engineers. So this is a very fast introduction of the role of each one in the project. Do you have any questions?
No, not so far.
Okay, let's start with the do you see the slide?
Sorry?
Do you see the slide now?
Yeah.
Refrigeration cycle components, right?
Yeah.
Okay, so from here we will begin the physics behind the HVAC industry. And that is the intent of the course, right?
Thermal capacity, thermal units.
You are with me, right?
Yes. I'm with you.
Okay, so we will start with
Air conditioning system classifications.
yes, we will start with the basics of the refrigeration cycle. How can we provide cooling?
Okay.
Like I said in the beginning of the lecture, if you have a hot cup of coffee next to a cold cup of ice, the flow of heat transfer. Do you know the heat transfer?
Heat transfer?
Yes.
No, I don't know.
Okay, heat is the amount of energy that is transferred from high temperature medium to low temperature medium.
Heat. So it transfers through high temperature.
From high temperature medium to low temperature medium.
Okay.
That is heat.
That is it. Heat.
So you know the voltage and the current.
Yeah.
Okay, so why the current is moving from one point to another? If you have a simple electrical circuit.
Yeah, because they put wires in every electricity wires.
I don't hear you. What did you say?
Because of the wires.
Yes, wires. Wires is the medium where electricity moves, right?
But
But what makes the current moves from one point to another? What makes the hot cup of coffee get cooled when you leave him in the ambient temperature? Have you ever thought of this phenomenon?
no.
Okay, so anything in the wood is looking for the equilibrium. What is the equilibrium? It's the process of being similar to the surroundings around him. So if you put a hot cup of coffee in a cold room, the cup of coffee tends to be cold like the rest of the room.
Hmm.
Am I saying anything difficult?
No. See, there is some. I am.
I don't hear you.
I am familiar with some of these points, but refrigerant cycle components and then refrigerant cycle thermal capacity, thermal units. I'm not familiar with this. You see, my so I am.
Okay,
I want to know in depth with. Are you in depth in with? I want to know in depth.
don't worry, we will know everything in this course, inshallah. Don't worry. I need you to be calm and relax
Yeah.
and try to understand.
Uh, I am relaxed, but I don't know. I'm really hopeful that after finishing that course, I'm gonna learn something with your help, of course.
Okay, you will definitely gonna learn a lot of things,
Hopefully, inshallah.
inshallah. So we are now studying the refrigeration cycle. So what is the idea behind the refrigeration? We are talking about that heat is moving from high temperature to low temperature medium, right? You
Yeah,
have a hot cup of coffee, it heats the cup of ice, right?
yeah.
Okay, so
See, yeah.
what?
By the literal meaning, when I put a hot cup of tea in a place, in any place, it gets cold
Why it gets cold?
because high temperature, the coffee is high temperature and the outside air is not.
Yes, very good, excellent. It is a simple answer because it's high temperature and the surrounding is at a low temperature.
Low temperature, yeah, high
Okay, so is this the process that happens in
air condition.
HVAC? Yes. You
Uh,
have at case A, the outdoor is at 46 degree, right?
yeah.
Okay, and the indoor is at 24 degrees.
Now it, no,
So
the normal rule I guess does not apply in HVAC.
yes, this is the weird or different thing about HVAC.
Ah,
So the air conditioner in your house, what it makes, it extracts heating or extracts the cooling from inside the space, which is at 24 degrees Celsius, to the outside, which is at 46, right?
hmm. Can you repeat? Sorry.
Okay, we will repeat.
Yeah.
You at your office now, the
Yeah.
temperature is 24 degrees Celsius, right?
Okay.
Outside, the temperature is 46.
Yeah.
So the air conditioner
Mhm.
moves the heat from inside your room, right, to the outside.
Ah, yes, yes, yes. The returner and the supplier. The supplier will supply
Yes.
uh, cold air,
If you
and
think
returner will.
about the idea of the cup of coffee,
Yeah,
where
yeah.
the temperature moves from the high temperature the high temperature medium to the low temperature medium. This is the opposite idea of the HVAC. The HVAC, the heat moves from the low temperature medium to a higher temperature medium, right? The heat
Mhm.
in the space, because what makes the temperature in the space 30 degree is the heating inside the space, right? The load, the lighting, the equipment inside the space, which is the component of the cooling load, right?
Yeah.
So if you have a meeting room, the meeting room has one person.
Okay.
It is the same load as if the meeting room has 30 persons.
Mm, uh, can you repeat the question again?
Okay, so in your work, you are in
Yeah.
your office. Okay, you are in your office,
Yeah.
and you are setting the temperature of the air conditioner at 24 degrees Celsius, right?
Okay.
So if all the site workers in your site come to sit with you in the office,
Okay.
do you still feel the same temperature?
No, 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 no.
Why?
Because if more people shares the room, there is a heat from human body.
Yes, excellent.
Yeah.
So people, lighting, and equipment are the main source of heat, right?
Yes. Yes.
So we install
Yeah.
an AC, a split unit in
Okay.
your home. What
Okay.
does the split unit do? It extracts the heat from the people, the lighting, the equipment
Yeah.
from inside Musharraf home to the outside.
Yeah.
But the question is how the air conditioner moves the heat from a 24 degrees Celsius space to the
Yeah.
outdoor, which is 46, where the Muhammad said that the heat moves from the high temperature to low temperature. Do you understand what is the
Yeah. Yeah.
problem?
Yeah. 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 I understand. This is that I don't know.
You don't know.
No, I cannot
Okay.
think of an answer for that.
Yes. We still don't know the answer. So we will start with the refrigeration cycle components. How this indoor unit, which is installed inside your home,
Okay.
and this outdoor unit, which is installed in your balcony or in the outdoor.
Anywhere. Anywhere, but not inside my house.
What? Anywhere, yes, anywhere, but not inside the home.
Yeah.
Okay. So how is the cooling is produced in this machine?
Through Freon. Freon is helping.
Yes, through Freon, right? So how Freon works? So we have to clear our mind to understand that the air conditioner moves the heat from the cold space, which is inside Musharraf home, to the
Yeah.
hot outside Musharraf home, right?
Yes.
So let's speak in a more scientific way.
Mm.
This the indoor unit is called in science an evaporator, whereas the outdoor unit is called a condenser. Okay,
Condenser. Yeah.
so what is meant by an evaporator?
Evaporator.
What's meant by evaporation?
Mm, I don't know. Hello?
Evaporation process changing the liquid. Hello,
Yes, yes.
do you hear me?
Yes, yes. Now I do.
Okay, what operation is the process of converting the material from liquid phase to the vapor phase. So if you
Okay.
have a kettle in your home, you are making tea or a cup of coffee. You put
Okay.
water, right? And
Yeah.
switch on the heater, right?
Yeah.
What happens after that?
Then the water gets boiled.
Yes, excellent. This boiling is called evaporation because
Oh,
some of the water is changed from the liquid phase. What do you mean? Do you know what I meant by liquid, right? Like
yeah, yeah,
water. To vapor phase. Vapor phase like gas,
yeah.
like air. Okay,
Okay.
you understand this issue?
Yes, yes. So this
Okay,
what I'm.
okay. So the indoor unit is the evaporator. Why it is called the evaporator? Because the Freon, like you said, is changed from the liquid phase
Okay.
to the vapor phase.
Okay.
So if it is going to change from liquid phase to vapor phase, it has to be heated or cooled.
Cool. No, no, no. It has to be warm.
Yes.
It has
So from where we can get the warm air?
outside outdoor unit or outside.
No. The evaporator we say that the evaporator is the indoor unit, right?
Yes, yes.
Okay. The Freon temperature is around 2 degrees Celsius.
Okay.
It's above zero.
Oh, okay.
So relative to the ambient temperature or the space temperature, which is at 24 degrees Celsius,
Hmm.
the ambient temperature is hotter than the Freon, right?
Yes.
So the space here is heating the Freon.
Oh, okay, okay.
Do you
Now I
understand?
am. Yes, yes, yes.
So the Freon changes from its liquid phase
To vapor phase
to vapor phase by absorbing heat from the space.
from the space itself. Yeah, okay. Understand.
Are we okay
Yes.
with this process? Evaporation. And do you know now why it is called an evaporator, right?
Yes, yes, I do know.
Because the refrigerant or the Freon is evaporated,
Yeah,
right?
understood.
Okay, so when we change the refrigerant from the liquid to the vapor phase, okay,
Hmm. Yeah, okay.
this is the vapor phase. The refrigerant is hot or cold?
Cold.
Okay, relative to the environment, it is hot or cold?
The what? The
Relative to the
refrigerant?
space, it is hot. It is hot or cold?
The vapor or liquid?
The vapor.
Vapor is cold, right?
Yes.
Yeah.
So after it changes into vapor, it enters a mechanical compressor.
Okay.
The compressor is in the outdoor unit.
In the outer unit, yeah.
Yeah, this is the one with the large noise.
Yeah, which is why we put it outside of the home.
Yes, excellent. This is why we install it at the outside of the building.
Yeah.
There is another reason why we install the outdoor unit in the outside. We will know that. So
Okay.
when we absorb heat from the space, okay, we want to reject this heat to the outdoor, right?
Yeah.
So we are trying to move the heat from a 24 degrees Celsius space to a 46 outdoors, right?
Yeah.
So to do this process, we cannot do this process normally. We have to provide work. We have to pay money for doing this job. because the job is against nature, right? Hello?
Yes. Hello?
We are agreeing that temperature or heat moves from from hot to cold, right?
Yes.
So now Musharraf needs to absorb heat from his cool space to the hot outdoor. Is this possible?
No. Not.
No. So Musharraf has to pay money.
Yeah.
What is the money he is going to pay? He is going to pay work. Work is delivered through the mechanical compressor.
Yeah.
So the importance of the compressor. What does the compressor do?
The compressor will absorb the heat.
No, it will not absorb the heat. It will make us take the heat from the evaporator and throw it in the condenser.
Condenser, yeah.
Okay, so heat in this evaporator, we will absorb it through a mechanical compressor by providing power. The power is provided, the vapor is converted from cold vapor to hot vapor.
Hot vapor, yeah.
Okay, so the hot vapor now is hotter than the environment. It will be at 80 degrees or 70 degrees.
Yeah.
So 70 degrees is greater than the outside, which is at 46, right?
Yeah.
So we can easily reject the heat to the outdoors.
What is an expansion valve?
Okay, this is a good question. So if we took the heat from the evaporator and we provide power through the compressor rises the temperature of the vapor to allow it to reject the heat to the environment. Okay, through this fan. Because the vapor is at 70 degrees and the environment is at 46 degrees, so the heat is rejected from the condenser to the outside. Do we agree about this?
Yeah.
Okay, so what guarantees that this cycle continues to work? You are operating your air conditioning in case 24 hours per day, right? So what guarantees that the process is and the cycle is repeated once more, once more, once more? This is the function of the expansion valve. After we condense, what is meant by condenser or condensation? Condensation is the opposite of evaporation, where the vapor refrigerant is condensed. Condensed means that it is changed into the liquid phase. Any problem?
No, not.
Okay, so the vapor here is changed into liquid, right?
Yeah.
So we have hot liquid or cold liquid here?
Hot.
Hot. Excellent. So this hot liquid needs to be cold.
Yeah.
To remove the heat from the space, right?
Yes.
So this is the function of the expansion valve. If you have a hot liquid and you put an expansion valve, by a process that we will know right now, it converts the heat of the liquid into being a cold refrigerant.
Yeah.
So can you explain to me how can we provide cooling through this cycle?
Yeah, I can give it a try.
Okay.
Yeah, after installing indoor, what do you know by evaporator and then condenser. See the liquid from the condenser, the warm liquid from the condenser will first go to the expansion valve. Then the expansion valve will convert it to cold liquid, and the cold liquid will go to the indoor unit as vapor, right?
Right.
So the vapor then will supply the The vapor will then go to the mechanical compressor. Mechanical compressor then will pass it to the condenser.
So the
Yep.
function of the evaporator is to extract the heat from
Extract heat from inside, indoor to outdoor.
yes, and the function of the condenser is to reject heat to the
To the outside area.
yes, excellent. So and the function of the expansion valve
Is to uh, make sure that the heat liquid gets cooled.
okay, excellent. So the indoor unit is cold.
Yeah.
It's called an evaporator, right?
Yeah, cold and evaporator, indoor units. And the outdoor units is condenser.
Okay.
This part is clear now.
This part is clear.
Yeah, I hope so. If I have any questions, I'll ask you in the next
Okay.
class. See, we are gonna review this topic next class, right?
Yes,
For
we
a
will have
revision.
a fast recap before every session.
Yeah, then I'll ask my question once we recap the
Yes.
chapter or topic.
Okay, we agree today. We agree now. So this is a more elaboration of the circuit. This is the evaporator,
Yeah, indoor
the suction to the compressor,
suction line. Suction line as in the freon line, right?
is the line which contains vapor refrigerant,
Yeah, yeah, yeah.
cold line. Then we add power through the compressor to the discharge line.
Discharge line. Yeah.
Okay, this discharge line it enters through the condenser and the fan is cooling the vapor. It returns to a liquid line, right?
Yeah.
Then through the expansion valve, it returns to be cold,
Evaporate.
a cold liquid.
Yeah.
Okay, so the cooling load is the Q. So we rename the heat by Q. The symbol of
Okay.
the heat is A is Q. Okay.
Okay.
So the cooling load, which is the people, like you said, the ventilation, the lighting, the motor, the equipment, anything inside the space is called the cooling load,
Yeah. Okay.
right? And we will know by details how to calculate the cooling load. The cooling load is named is Q evaporator, right? This is
Cooling
the
load
heat
is
from the space.
okay.
So Freon is used to remove heat either from air, like in direct expansion systems, which is the split unit,
Mhm.
or from water, which is a chilled water systems, like you see in a chiller.
Yeah.
In a chiller, the same process takes place, but we are cooling water, and the
Mm.
water is used to cool air at the building. You see the difference?
Yeah. I
So DX system or direct expansion system, systems that cool air directly through the freon.
mm,
So they are called direct expansion systems. While chilled water systems, no, the freon is cooling the coil, the freon is cooling the water,
mm,
and the water is used to cool the air.
okay.
You understand this part?
Yeah. Yeah. But chiller, I don't understand a lot, but chiller I need to
Okay,
understand.
we will study the chiller, but everything you need to know about now is that chiller, what is chilled water? Chilled water is a cold water that moves through the system. The refrigeration cycle extracts the heat from the water. So the water temperature decreases. becomes cold water here.
Okay.
Why? In the case of direct expansion, no. The refrigerant is cooling air. Right? In your office contains air. And the Freon is in the indoor unit, right? Here.
Yeah.
Okay. Air passes through the indoor unit and it gets cooled.
Yeah.
While in the case of the chiller, no. The indoor unit contains chilled water, not Freon
yeah.
or refrigerant. Okay. Where is the refrigerant? The refrigerant is at the chiller.
Okay.
So the chiller, so there is an intermediate medium between the Freon and the air.
Yeah. Okay.
Which is the chilled water. Do you understand now what is meant by chilled water system?
Yeah, partially, but I still have a lot of questions.
Okay, let's try again. Let's try again. In your space, in your office, you have an indoor split unit, right? Better?
Yes.
What's passing through this tubes? Freon, right?
Yeah.
Okay. What passes through the Freon? What gets cooled through the Freon?
What passes through the Freon?
Yes, what gets cooled by Freon?
By Freon, gas excludes the air. The
Air.
hot
Air
air.
is cooled. It is cooled using the Freon, right?
Yeah.
Okay. Remove air and put water.
Yeah. In the chiller. Yeah, I understand that part, but
But what?
no, but I have other chiller. I'll ask this question later because chiller is, I don't actually know a lot about chiller.
Okay. We'll start every part this session. So the compressor power
Yeah, compressor.
is the money we pay to make the heat move from the evaporator to the condenser, right?
Yeah.
Okay. That is the power we pay to make cooling. We understand to
Yeah.
reject the heat absorbed from the space to the environment. Do you agree on that, right?
Yes, I do.
Okay, so
So can you hold for a second?
okay.
Hello. Last one to see. কিছু না পঁচিশ না এখন বিজি আছে লেট হবে 11টা 11:30 12টা Hello?
Hello?
Yes, sir. Yes, I'm back.
Okay. So we now at the heat released from the condenser. So after the Freon has gained heat from the evaporator and the compressor, right?
The heat must
The
be
heat must
reduced.
be released.
Yeah.
So the condenser is cooling the Freon, right?
Yeah.
So we have two methods of cooling. We can cool by air
Or by water.
or by wood, right? By air is called air-cooled condenser. By water is called water-cooled condenser. So from your experience or from your thinking, who is more efficient? Which is more efficient? By cooling by air or cooling by water?
Cooling by water.
Why?
Because cooling by water, you see the air-cooled system. I don't know. I give up on that. You explain.
No, we need to think. We are here to learn.
Yeah.
So what do you think?
Because I think the temperature of water is lesser than
No,
air.
because the heat capacity of the water is larger than the heat capacity of air.
Ah, okay.
No,
Okay.
no, it is very difficult terms. Try to be nice to me, right?
Yes,
What is
yes,
the heat
yes.
capacity? Something like that. So heat capacity is the amount of heat needed to change the water from a liquid phase to vapor phase. So
Heat-
heat capacity
yeah.
means the amount of energy you need to rise the temperature of the water by 1 degree Celsius.
Hmm.
This
Okay.
is this heat capacity is larger than that of air by 4 times.
Oh, okay.
So water is good coolant
Hmm.
than air.
Yeah.
Okay, we will now how to describe the efficiency of the refrigeration cycle. How can we say that this cycle is efficient, this cycle is inefficient, this cycle is good, this cycle is bad? How can we estimate uh, the efficiency of this system? There is a term in refrigeration cycle called the coefficient of performance.
Hmm.
What is coefficient of performance? It is the Q evaporator over the compressor power.
Hmm.
So what is the main output of the cycle? You have this cycle right now. We explain, right? What do I need from this cycle?
The cycle.
Yes. What is the purpose of the refrigeration cycle?
I do.
Hello?
Yes, yes, I can hear you.
Why do we use a refrigeration cycle? We
It's
use
to get
refrigeration
cold air.
cycle, yes, to cool the air. So we use this cycle to remove the heat from the space, right?
Yes, yes.
So what is the important term in the cycle? The important term is the heat
Hmm. It gets.
extracted from the space, right?
Yeah.
Okay, this is the Q evaporator, right? This
Yeah.
is the cooling load.
Hmm.
This is what I am purchasing or buying the cycle or the refrigeration cycle or what I am buying the chiller, the split unit, the DX unit for it, right?
Yes, yes.
Okay, so what I'm buying, the main purpose of this is the evaporator, the Q evaporator,
Yeah.
the heat rejected from the state. So what is the price that I pay? What the sacrifice that I have to do to make the heat go from the inside space to the outside outdoors? We use compressor, right?
Compressor. Yeah.
So what I am having, what I am gaining is the cooling load, which is the Q evaporator. What I'm paying for is the compressor power, right?
Compressor power. Yeah.
Okay, so the coefficient of performance is the ratio of the Q evaporator to the compressor power. So you are a contractor now, and you need to install the split unit. And one told you that we have a split unit of COP10, while the other one told you that we have a split unit of COP5.
Hmm.
What, which of them do you choose to install in your building? One
Sorry.
with COP10 or one with COP5?
Now, can you repeat this part? I
Okay,
kind of missed.
you now are a contractor, right?
Yeah.
Okay, the owner told you that he has two split units.
Mm.
One with COP 10,
Mm.
COP equal 10, or one with COP equal 5.
Mm.
What split unit will you install in your building?
COP as in COP. What is COP? Oh, about the compressor 10.
What?
No, are you talking about calculating of the area, something like that?
No, I'm asking about the coefficient of performance. The coefficient of performance is called COP. Okay.
Okay.
We explained that the COP is the gain that I have gain benefit from, which is the cooling load, the Q evaporator, right?
Yeah.
Over divided by the compressor power, right? Which is I paying for.
Yeah.
So one told you which is better, COB equal to 10 or COB equal to 5
Mm.
from an efficiency point of view, which is better?
CAP is equal to 10
Why?
because you'll have more air.
Because what I have,
More air. I mean,
you don't have more air here. You have you buy 10 units of cooling
yeah.
by 1 unit of power, right?
Yeah.
Where there you buy 5 units of cooling by 1 unit of power. So
Okay. 5
increasing,
year.
okay,
Please. Continue. Hello.
hello,
Yes, you're saying.
what is your question?
No. No question. I just.
So explain to me why COP10 is better than COP5.
Because COP means I.
Because the coefficient of performance means the gain, what I make use of, which is the Q evaporator
Mm.
over the compressor power.
Mm.
So the compressor power, this is what I pay for, while what I gain, what I make benefit from is the evaporator, the Q evaporator. So if I increase the gain and decrease the amount of paying, the amount of money, this is gonna be more efficient to me, right?
Yeah.
So increasing the COP is better to the engineer.
Mm.
And as the COP increases, the device is more efficient.
Mm.
Okay?
Okay.
Do we understand this part?
Yeah.
Okay.
See.
So we will go deep through how to calculate the evaporator, the heat absorbed by the evaporator, and how to calculate the work of the compressor
Mm.
to determine the COP.
Yeah. We have already discussed that part, right?
Yes, but we have to determine the amount we have to calculate. How can you calculate the amount of heat absorbed by the evaporator? How can you calculate the heat rejected by the condenser? Do you understand?
Yeah, I understand, but I don't know how.
Okay, so we will learn now what to do. So,
Okay.
do you have an engineering background or something like that?
Yeah, I don't. See, I have done couple of courses like this, but I did LLB honors.
I don't hear you.
See, my background is law. I did law first. LLB.
Oh, hello.
Yeah.
You're in actual a lawyer.
Yeah, yeah.
Okay. But you are working in the field of construction, no?
Yeah, right now I am actually. But my honor
Okay,
certificate is on law, so which is why you see there was a mistake while planning the career and all that.
okay, no problem. We will learn everything.
Yeah.
So to determine the coefficient of performance, which is the heat absorbed divided by the energy consumed or the work of the compressor, we have to determine first what is the heat absorbed by the evaporator. The heat absorbed by the evaporator is equal to the mass flow rate. You know the mass flow rate?
No.
Mass flow rate is the amount of the freon per second in kilogram per second.
Per second, freon.
Yes. How many freon passes through the pipe per second?
Ah, okay.
This is what is meant by the mass flow rate.
Okay.
So by multiplying mass flow rate of the refrigerant or the freon by the difference between H2 and H1. What is meant by H? H is the energy of the freon. So let's remember this cycle. We don't change anything this cycle, right?
No.
So, okay. So I need to calculate the amount of the amount of Q evaporated. The amount of the heat absorbed from the space is the amount of equal to the amount of the heat that the freon is heated by, right? The freon is liquid, cold liquid. The freon is evaporized and changed into vapor. So the difference between the energy of the inlet state of the freon and the outlet state of the freon is the cooling load or the Q evaporator, right?
Yeah, right.
So again, let's apply this rule to the condenser. The amount of the heat rejected into the outdoors equal to the amount of the heat the evaporator, the freon lost in a vapor phase to change to liquid phase, right?
Yes.
Do you understand something like that?
Yeah.
Okay. The amount of power added to the system or added to the freon to change it from vapor, cold vapor to hot vapor is the amount of rising the temperature of the vapor from this phase to this phase, right?
Yeah.
That's the four question, the four equation. So after evaporation, before evaporation, the amount, this is a pH diagram. We need to enter through these deep details, but we will wrap it up as fast as we can to go through the elements of the air conditioning systems. At first, we have before the evaporation, state 1. State 1, after evaporation of the freon, it reaches to state 2. Okay?
Yeah, okay.
So the amount of the Q evaporation is the M dot refrigerant or the flow rate of the refrigerant or the freon multiplied by the H2 minus H1, the difference, like we said.
H2 minus H1, okay.
Okay, so work by compressor is the refrigerant, flow refrigerant, multiplied by H3 minus H2, which is after the compression.
H3
Okay, That's
Okay.
the amount we pay to the cycle to get cooling.
Mm.
When we reach the step 3, the refrigerant returns to step 4 in the condenser, right?
Yeah.
So the amount of Q condenser is flow rate of the refrigerant multiplied by H3 minus H4 or H1 because they have the same H.
Mm. H3
So
minus H4 all one. Okay.
yes, because this is the x-axis, we have this H. So 1 equal 4 because they have the same vertical line.
Okay.
This process happens in the expansion valve. So the importance of the expansion valve, if it were not for the expansion valve, the cycle would stop at 4. It will not repeat itself.
Mm.
So we have to move from point 4 to point 1 through the expansion valve.
Yeah.
Okay? So can you tell me what is the COP now? The COP is the coefficient of performance, right?
Mm, yeah.
We agree that the COP is the heat absorbed
Yeah.
or
And
the Q evaporator or over the power of the compressor, right?
yeah.
And the more it gets, the more it is more efficient, right?
Mm.
So COP10 better than COP9, better than COP8, right?
But, yeah.
Okay. So heat absorbed is the Q evaporator, right? From here, this equation over the work by the compressor, right?
Yes.
So since the M refrigerant is the same in both equations, so by dividing this equation over this equation, we reach to the conclusion that the coefficient of performance is H2 minus H1 over H3 minus H2.
Mm.
Okay?
Okay.
So let's forget about these equations. We need to know the basic principles. What is the basic principle? That the CP is the Q evaporator over the compressor wall. Okay?
Okay.
So this is the same cycle. We illustrate it more further.
Mm.
Let's speak about the thermal unit. Let's speak about the thermal unit.
Okay.
So when you buy your apartment and you want to install a split unit inside it, everybody tell you that the split unit is 1 horsepower, 2 horsepower, 3 horsepower, right?
Yes.
What is meant by horsepower?
Horsepower is to level the power of the unit.
Yes, it's a unit of power, right?
Yeah.
So we at HVAC determine the unit of the power of the evaporator or the cooling load of the evaporator by ton refrigerant, which is a unit also, TR.
Yeah. Yeah. Ton, right?
You know ton refrigerant?
10 refrigerant. 10 refrigerant. Yeah. I
Yes,
know.
TR.
Yeah. Yeah.
Okay, that's good. 1 ton refrigerant equals 3.52 kilowatt.
Yeah.
Okay, this is a conversion.
Mm.
1 ton refrigerant equal by British thermal units equal to 12,000 British thermal units per hour.
Yeah. We 12,000 BTU. Okay.
You know this conversion, right?
Yeah.
Okay. So 1 horsepower equal to 8,000 BTU per hour.
1 horsepower is equal to 8,000 BTU per hour.
Yes, which is 2 over 3 ton refrigerant.
But 3.24 kilowatt.
Yes, if you multiply 2 over 3 by 3.4, it gets to 2.34 kilowatt.
So,
So which is greater, the ton refrigerant or the horsepower?
horsepower.
Is greater than ton refrigerant?
Yeah.
No. The horsepower is 8,000 BTU per hour.
BTU, yeah, BTU per hour, but the ton
It's 12,000.
12,000 BTU, yeah.
Yes, so the horsepower is lower than the ton.
Then, yeah.
The
So, which
horsepower is equal to 2/3
yeah.
of the ton.
Okay.
Okay, so if you have a split unit at your home right in front of you now,
Yeah.
equal to 1.5 horsepower.
Okay.
Right? Yeah, you hear this expression, 1.5 horsepower, 3 horsepower, 5 horsepower, right?
Yeah.
So, what is the equivalent ton refrigerant of 1.5 horsepower?
3/4.
How many ton refrigerant?
3/3.5, I guess. Right?
So, if you have the 1 horsepower, is 2/3 ton
2.
refrigerant.
Yeah.
So, if I have 1.5 horsepower, it will be equal to how many ton refrigerant?
How many ton?
Yes.
3/4.5.
Now let's do it. Together. We have 1 horsepower equal 2/3 ton refrigerant. Okay.
Yeah.
So if I have 3/2, مش 1.5 horsepower is 3/2, right?
3/2.
Yes.
Yeah.
So if I have 3/2 horsepower, it will be equal to how many ton?
It's less than 1.
No, it will be equal to 1 ton refrigerant.
Oh, okay.
Okay, so because 1 horsepower equal 2/3 tons, so if we increase it to 1.5 horsepower, it will be 1/3 plus 2/3, it leads to 1 ton refrigerant. So the split unit installed in your room is 1.5 horsepower, which is equal to 1 ton. Understand?
Yeah.
Okay. So let's speak about the classification of the air conditioning systems. Okay?
Okay.
So we now know, you now know how can we provide cooling, right?
Yeah.
How can we remove heat from the space and send it to the hot outdoors? We should do it through a refrigeration cycle, right?
Yeah.
What are the components of the refrigeration cycle?
The refrigeration cycle?
Yes. This is the refrigeration cycle. What are the components of the refrigeration cycle? What makes the refrigeration cycle? The refrigeration cycle has 4 components, right?
Yeah. Evaporator, expansion valve, compressor, and condenser.
Yes.
Yeah.
Right or wrong?
Yes. Right. Expansion valve, evaporator, compressor, condenser.
So we have taken a lot today. Let's take a break of 10 minutes. Or do you want to continue?
Let's continue because I will finish then I'll go.
I don't hear you.
See, I have to. It's better if you can finish as soon as possible.
Do you want to finish as soon as possible?
Yes, because I have duties tomorrow morning.
Okay, so let's continue.
Yeah, I'm sorry. Maybe you're feeling exhausted too.
No. I am speaking for you because I know that there are too much information we are telling today, which may
Yeah.
be new to you and maybe needs to memorize them and understand them well.
See,
But I'm with
you're
you.
gonna send this.
Yes.
You're
Yes,
gonna,
I
are
will
you gonna
send you
send
the
this?
material.
Yeah.
The center, the coordinator will send you the materials that I explained today. And
Okay.
there will be an exam in the next session, okay?
Mhm. Okay.
And it even may be a verbal or an oral exam to save time.
Mhm.
And we will have a fast recap at the first half an hour of each session.
Okay.
Okay, this is good for you.
Yeah, it is fine.
Okay, we will have session on Sunday and Wednesday
Okay.
at
I
the
already
same
know
time.
that.
Okay.
Yeah. Okay.
Okay, so let's continue.
Mhm.
So we classified the air conditioning systems into two main parts: DX systems.
The
What is
access.
meant by DX systems?
Anything but
Direct
chiller. All kind.
expansion systems.
Yeah, direct expansion system. Okay. The access.
Okay.
Yeah.
Okay. The direct expansion systems. What do we say about the direct expansion systems?
Direct expansion system includes split units, which
Yes.
is
Why they are called the direct expansion?
because they directly deals with air. Hello.
Hello?
Yeah,
Why they are called direct expansion systems?
because it is it absorbs the air and then heat air and then gets it cold directly, not from water.
I don't hear you.
Hello. Yeah,
Oh,
because it works with air directly.
voice is
Is
not
that-
clear. Hello?
Hello. Yes, sir.
Yes. Why it's called direct expansion?
Because it directly works with air.
Yes. Excellent. So direct expansion because the freon, the refrigerant,
Mhm.
cools the air directly,
Yeah.
while chilled water systems, the freon cools the
Water.
great, and the water cools the
Air.
great. So what are the types of the DX systems?
Mm.
First type and simplest type is the split unit in
Yeah.
your home.
And everywhere actually.
Yes, in indoor and outdoor units, right?
Yes.
Okay. Second, there's a type called VRF. What's VRF? Variable
VRF.
variable refrigerant flow.
Variable refrigerant flow. Yeah. Okay.
We will know what is variable refrigerant flow now.
Yeah. Okay.
Third type is AHU. What is meant by AHU?
Air handling unit.
Excellent. And the condensing unit.
Yeah.
FAHU.
I
Fresh
don't know.
air handling unit.
Fresh air handling unit. Okay.
Yes. What is the difference between air handling unit and the fresh air handling unit?
I don't know actually.
Okay, air handling unit, if you want to cool a space, okay, so you provide a supply duct
And the return duct.
and return duct, okay?
Yeah.
So the AHU contains a supply duct where you provide all the flow needed by the space, and a return duct where you extract, return to the machine or the equipment around 80%, 70% of the flow to the equipment through the return air duct. So where does the 30% come from? 30%.
The fresh AFHO, fresh air duct, right?
Yes. So in air handling unit, the fresh air coming from outdoor, because every space needs fresh air, right?
Yeah.
To remove the contamination in the space, to increase the oxygen percentage, to decrease the carbon dioxide percentage inside the space, right? So people can breathe. You understand this issue?
Yes.
Why do you want fresh air?
Because if there is no fresh air, the room will probably get smelly. And
Yes, excellent. Because if there is no fresh air, contaminants and the pollutants and smells inside the room will increase.
yeah.
So we have to insert a new air, a clean air, which is called the fresh air.
Yes.
So by inserting fresh air, which is at 46 degrees to the space, we have to pay a lot to cool this fresh air, right? Because we have to cool it from 46 to 24.
24, yeah.
So it is very expensive. So people think that we can insert a small percentage that is enough to remove the pollutants, remove the odors, remove the smells from the space, while the remaining air can be provided from the same room air, which is the return air. So we provide 100 liters per second. The 100 liters per second contains 30 liters per second fresh air and 70 liters per second return air.
Can you repeat?
Okay, so we have a space that needs 30 liters per second fresh air, okay?
Okay.
And the supply air is 100 liters per second. So we mix 70 liters per second of the return air of the coming from the space with the 30 liters per second coming from outdoor, and cool them again and supply them to the space. So the total fresh air in the space is 30 liters per second, which is enough for the space, while the cooling load is small because we cool 70% of the air from 24 degrees Celsius, not from 46. You understand this issue?
No.
Okay, let's repeat. If a space wants 100 liters per second, do you know liter per second, right?
Yes.
Okay, so if a space needs 100 liters per second, I can get the 100 liters per second from fresh air outdoor, right?
Yes.
Okay, so I will cool 100 liters per second from 46 degrees to 24.
24, yeah.
So what is the cooling load? The cooling load will be the flow rate, which is 100 liters per second.
100 liters per second, yeah.
Multiplies by the heat capacity, multiplies by the delta T, which is 46 minus 24.
46 minus, yeah.
Right?
Yeah.
This is the cooling load. So in the other case, to save money, we want only, the space wants only 30 liters per second fresh air. It doesn't want 100 liters per second fresh air. So I take 30 liters per second at 46 degrees, right, from the outside, and mix it from 70 liters per second from the space, which is at 24. By mixing the outdoor air with the return air, the resultant air temperature will be around 30 liters per second.
So 30 liters per second is the
temperature of the mixing air.
Yes.
So the cooling load will be 100 liters per second, multiply the heat capacity, multiply by 30 minus 24, right?
Yeah.
So which is lower than the case in the case of the fresh air, right?
Yeah.
So here we have two advantages. We provide the fresh air needed by the space without overestimating, and we reduce the cooling load, right?
Yeah.
So this is the main difference between the AHU and the fresh air handling unit. Okay? The fresh air handling unit doesn't have a return duct.
Oh, okay.
Because it gets the fresh air from the outside and supplies it directly to the space.
Yeah.
While the air handling unit has a return duct because it returns some of the air of the space to be mixed with the fresh air coming from the outside. Do you understand?
Yes, yes.
Okay. Number 5 is the crack unit or the computer room air conditioning, which is a type of DX system that is used in computer rooms. We will study it in details.
Yeah, this is completely new.
What?
CRAC.
Yes,
computer
it's called crack.
Crack, yeah.
Crack, yeah. And last type of DX systems is rooftop packaged unit.
Yeah, I'm very familiar with this.
What?
Package unit, I know.
Yes, it is installed on the roof.
Yeah.
And they have also supply duct and return duct and the fresh air duct, right?
Yeah.
So you connect these ducts to the machine and to the space directly.
Yeah.
But it is installed in the roof.
The roof, yeah.
Okay. So this is the components of the DX systems. Let us see what are the components in the chilled water systems. The chilled water systems consists of two types: water side equipment and air side equipment.
Yeah.
Why there is water side equipment and air side equipment? Because there is some parts that are cooled using the freon, which is the water side equipment. And then which water side means that they are dealing with water as the medium. While air side equipment is dealing with the air. So air handling unit deals with air.
Yeah.
Fan coil unit deals with air, right?
Yeah.
Recovery unit or crack unit or VRF deals with air.
Yeah.
While water cooled chiller deals with water. It cools water, right?
Yes.
Air cooled chiller cools water. Chilled water pumps circulate the water inside the network. Okay, cooling towers cool the water through the air. Okay, and the condenser pumps, expansion tanks, and the air separator. So let's start with the DX units. Okay.
Yeah.
The most familiar one, which is the window type. Do you remember the window type? It was an old version of the split units.
Yes.
Okay, so window type. This is the picture of the window type. It has the same idea. It has an evaporator which is inside the space. and mounted directly the condenser at the outdoor unit.
Yeah.
So they are attached to each other only, nothing else.
Mm.
The indoor unit, which is inside the room, consists of the blower or the fan
Mm.
with the cooling coil. What is the name of this part?
This part. Mm.
It's called the evaporator. Do you remember?
Evaporator. Yeah. Evaporator. I
Where
thought.
the refrigerant is evaporated by removing heat from the space.
Yeah.
So then it goes through the compressor, which is
Yeah.
installed in the outdoor unit.
Yeah.
The compressor switches or moves the refrigerant in the outdoor unit, which is the condenser coils, right?
Yep.
So now we can relate between the physics we study at the beginning of the lecture and by practical experience, right? So if you look now at window type air condition, you can tell where is the evaporator, which is in the indoor unit, where is the compressor or the condenser, which is the outdoor unit, right?
Yep.
So you will see it from inside as a contactor.
Mm.
So you are now understanding what makes the DX unit, what makes the window type unit. So
Yeah.
I need you, while we are studying, to take notes, because the thing you will remember from the course.
Yeah. I'm taking notes.
Okay. So window type air conditioner, the capacity reaches to 2 ton.
This is the last. I mean, 2 ton. There isn't any window top. This is 3 ton, right?
Yes, there
2 ton
is
is the highest.
but it's 2 ton is equivalent to how many horsepower?
Horsepower.
Yes,
1 horsepower is yeah, 3, right?
right.
2 ton is equal to 3 horsepower, right?
1 horsepower equals to 2 over 3 ton.
Yeah,
So if you have 2 ton, it will be equivalent to how many horsepower?
3, right? Isn't it?
Yes, it will be equal to 3 horsepower.
Yeah.
So in the market you have 1.5 horsepower, you have 2.25 horsepower, right?
Mm.
You have 2.5 horsepower and you have 3 horsepower, right?
Yeah.
3 horsepower, which is equivalent to 2 ton refrigerant,
Mm.
right?
Yeah.
So the capacity of the window type doesn't exceed 3 horsepower.
Okay.
There is no 5 horsepower from this unit. 5 horsepower is the standing unit, which is in mosques.
Yeah.
That's
Standing unit.
yes, the one which is very tall.
Yeah. Huh.
Yeah. This is 5 horsepower. Okay?
Okay.
Okay. So what is the advantages of this window type air conditioning system? It is simple, right?
Yeah.
It is cheap, not expensive, right?
Mm. Yeah.
It can be used in many applications, right?
Yeah. Good.
Okay, this is the advantages. But what are the disadvantages?
Very, you have to you have to make space for this
Yes,
unit.
you have to cut your wall
Yeah.
for this huge volume.
And also it kind of makes the look bad of the building.
Yes, it makes the building looks ugly.
Yeah.
It is not environmentally friendly.
Yeah, and also it is not suitable for rich people.
Yes, I am very happy with your brainstorming and your interaction with the lecture.
Yeah,
Moreover, it is very noisy,
yeah, yeah, it is also very noisy.
right?
Yeah, yeah, yeah.
Which
And
make people
also,
can't sleep.
you see, vibration of this unit, you can
Yes,
actually hear it. You know?
it makes large vibration.
Yeah,
Moreover, it can't distribute the air inside the space. It has
yeah,
fixed
yeah, yeah.
grills.
There's only one supply.
Yes, one supply and small supply with fixed grills. You can't make
Yeah,
the air moves throughout the room,
yeah,
right? Like you have diffusers or grills. You see
yeah,
malls and shopping centers.
yeah, yeah,
Every area is cooled and the air is reaching it. But in case of wind air conditioning, some area will be dead. There will be no air in this area. So it has very high noise, makes vibrations. It makes the building look ugly. We should cut the wall to install it. It has very bad air distribution. Okay? It has limited capacity also.
yeah.
Okay?
Yeah, okay. So for
So this is the remaining family of the DX unit,
oh,
which is the split unit. The split unit consists of an indoor unit, right?
yeah, yeah.
And an outdoor unit.
Hmm.
And they are connected together through refrigerant piping or freon piping, right?
Hmm.
This is mounted in the balcony or outside your home, and this is mounted inside the room, right?
Yeah.
Okay, there are different types. This is the high wall indoor. It is
Hmm.
called high wall because it is mounted at the highest the highest of the wall, right?
Yeah.
It cannot be mounted in the middle of the wall or at the ground, right?
Yeah.
Should be mounted near to the ceiling.
Near to the ceiling, yeah.
Yes. There is another one similar to it which has higher capacity, which is the ceiling split indoor unit, which is mounted in the ceiling. So this is mounted in the ceiling, and
Yeah.
this is mounted inside on the wall, right?
The wall, yeah.
Okay. There is another type which is it's called the cassette split indoor unit.
Hmm.
This exists in the shopping centers and in shops and retails and something like that. It is mounted in the ceiling. Have you seen this before?
Yes, yes, I did.
Okay, the all what can appear from the unit is this grill only, and this will be above the ceiling, right?
Yes.
You can see this part. You see only the grill.
Yeah.
So if you have a full ceiling, it's a very good option,
Yeah.
right? Okay. This is the last one, which is the freestanding we talk about, which is in mosques and in large meeting rooms, right?
Yeah.
This is has a higher capacity, which is 5 horsepower.
Hmm.
Do you have any questions here?
No. No
Okay, go
question.
on.
Yeah.
You have any questions?
No, 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 no. No questions so far.
Everything clear?
Yeah, so far.
Do you understand? Anything is missing?
No.
Okay, let's continue.
Yes.
So What is the properties of the split AC unit? It has high electricity consumption. Okay. It has low initial cost. It is cheap. It has low maintenance cost. You don't bring the technician to fix it except for 3 years or 4 years, right? It can live up to 10 years without replacing, right? Hello?
Yes.
Do you hear me?
Yes. Yes.
I'm talking about the split unit as a general.
Yes. Yes.
So it has limited lifetime, approximately 10 years, while systems like chilled water can exist for 25 years, right? Chiller and air handling unit and something like that.
Yes.
Okay. The capacity reaches 5 ton. 5 ton, which is 60,000 BTU per hour.
Okay.
5 ton is equal to how many horsepower?
5 ton is equals to 7.5.
Equal to 7.5 horsepower.
Yeah.
Okay.
Yeah.
The outdoor unit must be mounted on the building facade, right?
Yeah.
Okay. So indoor unit, the high wall one is compact. It is small in size compared to the ceiling unit and the cassette unit and the freestanding unit, right? This is the smallest one in size.
Yeah.
Typical applications, they are used in bedrooms. In your bedroom, you will find one like this, right? Okay, capacity up to 3 ton only. 3 ton, which is equivalent to how many horsepower?
3 ton.
Yes.
4.5.
Excellent. It has a built-in thermostat.
Yeah.
Where you can change the temperature from 24 to 23 to everything. So this unit can be exposed. What is meant by exposed? Exposed like this, you see the unit.
Yeah, I can see the unit. That's the
Concealed is, no, you can't see the unit. The unit will be mounted above the ceiling, okay? And there will be,
right?
There will be supply and return duct.
Yeah.
So it needs duct and air outlet. So you put a diffuser here in the ceiling or a grill, and this is a flexible duct where cold air exits from the unit and enters through the diffuser to the space. Whereas a return diffuser or a return grill collects the air from the space through the flexible duct to the equipment. This is the installation with the flexible duct. You see?
Yeah.
So this is mounted above the ceiling. This is neat duct and air outlet. It has higher cost because it is invisible to the people. So everyone don't want to see the air conditioning equipment, right?
Yeah.
The more you hide it, the more it is suitable for the people. It is used in living rooms, in bedrooms, and in offices. You in office, you will see something like that.
Yeah. Mostly in offices and commercial buildings.
Yes. Capacity up to 5 ton refrigerant. Okay.
So this is not duct split, right? This is
no. It is concealed duct. You have to mount the duct.
Ceiling mounted. Okay. Yeah.
Yes. So you have to insert the duct inside it. So it has higher capacity than the high wall or the exposed unit. So we said that it is mounted in the false ceiling. So it needs, and as per the picture here, this is the unit and this is the duct system. This is the outlets. This is the unit here. You see the mouse, right?
Yeah, yeah.
This is the unit, and this is the duct, and this is the outlet. So it needs about 40 centimeter in the ceiling.
This is a duct split unit, right?
Yes,
Okay.
this is a ducted split unit.
Mm.
It needs outlets and air ducts,
Mm.
and it has a thermostat.
Yeah.
So you see, this is in every hotel. When you enter any guest room in the hotel, you see something like that. That the ceiling at the entrance of the room is lower than that of the room, right?
Mm.
Because here they installed the tank unit or the split unit.
Yeah.
So it is concealed. It has a high, or it has high air distribution, and because it uses outlets and ducts, and it has better shape, right?
Yeah.
But you need to provide an access here to
For
change
the maintenance, yeah.
yes, for maintenance access hatch here. It will be from 60 to 60 centimeters. Yeah, the dimensions of the unit is 60 multiplied by 60 multiplied by 4. So it needs 40 centimeter depth in the ceiling with 60 multiplied by 60 access hatch under the unit. Okay?
Okay.
Do you take notes, right?
Yeah, yeah.
Okay. Any questions?
No.
Okay. So we will move to another system, which is the cassette unit, which is mounted also above the ceiling, and all what shows from the unit is the grill, right? So the cassette unit has two systems, which is 4-step swing, where this blades can be changed in all directions. So it has auto swing. When you have a remote controller of the AC, if you grab it now and look at it, you will see a button called swing. Swing means that the blade of the unit changes up and down, right and left to
Changes everywhere.
yes, change the flow direction for better distribution. There is two types from it. There is two-way, three-way, or four-way. What is two-way, three-way, or four-way? Two-way, where this plate, the air, and exits the unit from two directions only, from here or here. Three-way is the air exits from here, here, or here, and this no air comes from this side. So this side can be a wall. Okay, so it can be mounted inside next to a wall. This in this position. Here will be a wall, and the unit matches to left, right, and in front of them. Where the best one is the four-way, which is mounted in the middle of the room. So air can move in all directions, up, right, left, down. You understand?
Yes, yes.
Okay. So this is another shape of the cassette units. It is compact. It has a beautiful shape. It can be in receptions, in fast and food and beverage. This is the four-way. It is four-way is mounted in the middle of the ceiling, right?
Yeah.
For air to get from here, here.
Yeah.
So while two-way can be mounted in any locations, and it has also a round shape.
Yeah.
Okay. So another type is the ceiling mounted, which is the large one we see in pharmacies, shops, and bookshops. You see this is mounted under the ceiling.
I've seen them.
What?
No, I have seen those units.
Yes. This is they are mounted under the ceiling. You see they are exposed to people here.
Yeah.
And here. This is the ceiling mount.
Yeah.
Capacity reaches to 3.5 ton.
Mm.
We talk about the high wall.
Now freestanding unit.
Yes, floor standing. The floor standing unit has two shapes. The one in the mosques, prayer rooms, and the one in offices. They are mounted on the floor, so the air can come from out from the above. Here, the air come from here.
Yeah.
Okay? So the capacity of them reaches to 3.5 ton.
Okay.
Any questions till now?
No. No.
This part is easy, right?
Yeah. Yeah.
Okay.
Sort of. I hope all other parts are easy as this one.
All parts are easier from this one. You are clever and you, mashallah, understand well.
Huh. I really hope I think.
Inshallah.
Inshallah.
Okay. Let's continue.
Yeah.
Air conditioning systems, which are the direct expansion one.
VRF, right?
Yes, we are talking about a new technology, which is the VRF.
Yeah, this system is very new.
Yes, very new and very challenging.
Yeah,
Nobody
but it
understands the
another way
concept
it's
behind it.
cost efficient.
What?
It is cost efficient, you know.
Yes, it is the most efficient, right?
Yeah.
Good. If you no, not all engineers or contractors in the Middle East understand this system. It is very difficult because it is very efficient, like you said.
Yeah.
So what is meant by variable refrigerant flow? Yeah. What do you mean? What do you understand from this?
Yeah. See, there will be one outdoor, and by one outdoor we can have around 10 to 15 indoor units.
Right.
There will be one outdoor and above 5 to 10 indoors.
Yes. So it is one outdoor unit and
Yeah.
several indoor units.
Several
Right?
indoor units. Yeah.
Okay, this is good. So what is the properties of this unit? It can unfortunately have high electricity consumption. It is not very cheap and it is not very expensive. It has intermediate initial and maintenance cost.
Yeah.
The lifetime extends to 15 years. Like you said, we have only one outdoor unit and several indoor units.
Yeah.
We have concealed units, we have cassette units here, we have high wall split units, we have floor mounted, right?
Yes, yes.
All are connected to one outdoor unit.
Yeah.
The capacity reaches to 45 ton for
Right.
each system. So by having only one outdoor unit, it requires minimum space, right? Because if we install a DX simple system, each one of this would require a separate outdoor unit, right?
Yeah.
So by combining all of them to one outdoor unit, we
require kit.
Yes, we save space.
Yeah, yeah.
So how it works? It works if you open this unit and close this one. So the refrigerant goes to this unit only.
Yeah.
So, but if you are operating all the units, all the people are in their offices, so everyone is switching on his AC. So the refrigerant moves from the outdoor unit to all indoor units, right?
Yeah.
So the amount of refrigerant in the first case where this unit is operating alone is absolutely different from the second case. So this unit has the ability to vary the refrigerant flow.
This is why the name is variable refrigerant flow. Yeah,
Yes. So it has the ability to change the flow rate moving from the unit to the other units. So it can provide you 1 kilogram per second, 2 kilogram per second, 10 kilogram per second based on its capacity. This is the main advantage of this unit. So many units can be connected to it because if you are connecting all of them, it will produce the maximum capacity of the flow. If anyone is switched off or is working at port load, it will use less refrigerant. Okay?
Yeah.
Okay. So indoor units types are the same as the split units, as the normal split units we see, right?
Yes.
We see that indoor unit, split units, everything could be connected to 40 units based on the supplier.
Yeah.
It has more refrigerant pipe run, right? Because refrigerant pipes moves throughout the building.
Yeah.
To office of friend number 1, friend number 2, friend number 3, right?
Yes.
Okay. So here we talk about that it works throughout several cycles. Cycle number 1 has low flow rate. Cycle number 2 has an intermediate flow rate. Cycle number 3 has higher flow rate.
Okay.
Okay, so they can operate together by varying the refrigerant flow. In this case, we are talking about the outdoor unit of the VRF system. The green color means that, as you can see, in every unit, it has 2 compressors.
Yeah.
So every unit has 2 compressors. One is running by the green color, and one is in standby state. What is standby? Standby state is the state that it is not operating, but it can operate immediately to compensate the fault in another compressor. So if we are working through this unit, you see one compressor is working, right?
Yeah.
So if this compressor malfunctions or it is going in a maintenance or anything like that, the
other
second
compressor
compressor will operate.
Yeah.
Okay?
Yeah.
This is the main advantage of this VRF unit.
Can we take a break for 2 minutes?
Okay, for sure.
Okay, thank you.
Thank you.
Okay. Hello? Hello? Hello?
Hello?
Yeah.
Are we back?
Yes.
Okay. Let's continue.
Yeah.
So anything about the VRF unit?
VRF unit. No, this one it's clear.
It's
You see,
easy, right?
lately we had a lately as in last week we had a inquiry to install VRF system in a factory.
Yes.
So I was the one doing the survey.
Okay, that's good.
So I am familiar with VRF system. If everything clicks, probably we will be the one who's gonna install VRF system in that factory,
Inshallah.
inshallah. And the unit is from Carrier,
Yes,
same as
Carrier is
this
a
one.
very good supplier.
Yeah, see, Carrier is a well-reputed company all over the world, not like one
Yes.
place.
Carrier, York, and the train. All of
Yeah,
this.
I prefer train though. Train is the best according to me.
Mm,
And then Carrier, and then Yoke.
yes.
And there is here in Saudi, there is also a local company. I don't know if you ever heard of this, Al Zamel.
Yeah, Zamel. I know Zamel.
Yeah,
Zamel is good also, but
but
its quality is low.
I don't like their shape. It's very
Their shape.
their shape. Yeah, shape of the
Yes,
units.
but it's good to have something like that in Saudi Arabia.
Ah, yeah, yeah,
Manufacturing HVAC equipment is difficult.
yeah.
They are making outlets. They are making air handling units. They are good.
We work with both Carrier and Zamel in
Yeah.
Saudi. But we have difficulties installing a Zamel unit because of their sizes. It is really big.
Mm.
But I guess Carrier is more compact. It's very compact.
Yes, very
Yeah.
compact and very efficient with high quality.
Yeah, and also the quality. Yeah, quality.
Yeah. Okay, we will continue.
Yeah.
So
Hello.
one of the advantages of the VRF system is that you can hide the outdoor unit. You can install it in a mechanical room.
Mm.
The mechanical room where you provide adequate ventilation to provide the air that is going to cool the condenser, right?
Yeah.
Because it is supposed to be installed outdoors so that air can cool it freely.
Mm.
So if you put something like that in a room, you have to provide ventilation. You know ventilation, right?
Mm.
Right? You know ventilation?
Ventilation.
Yes.
Yeah.
So you have to provide ventilation to this unit if you put it inside a mechanical room.
Oh, okay.
So it can be cooled efficiently.
Mm.
And it has to exhaust the heat from the unit, right?
Mm.
So you should mount a duct in the unit to the outside of the building.
Mm.
So if the factory asked you to install a VRF unit, where you should put the outdoor unit of the system?
You're talking about my project.
Yes.
We already discussed that we are gonna make a platform of steel outside of the factory, just outside it.
Yes, that's the best option to install it outside.
Yeah.
So if they insisted that you will install it inside a mechanical room, what should you do?
Like you said, you'll have to. There must be some way to ventilate the room.
Yes, excellent. And there must be some way to extract the air from the unit to outside the room.
Mm.
So you have two concerns. You have to provide a fan to ventilate the room, and you have to provide an exhaust duct to ventilate to extract the air from inside the equipment. Okay.
Okay.
So this is how to connect it with the building automation system of the building using a control kit. This is the indoor unit, which is the DXHU.
Control kit is very expensive.
Yes, very expensive. How can you control both of them? You have to use a control kit, which controls the outdoor unit and the indoor unit.
Yeah.
Okay, and this control system is connected to the BMS system of the building.
Yeah, BMS.
You know, you are familiar with this term, right?
Yeah, BMS system.
Okay.
Distribution. Can we wrap it up for today?
Okay, you are enough with information, right?
Yeah, because I think
too much information today.
Yeah.
Okay.
I thought it will be an introduction class, something like that. But anyway, you explained a lot today.
Yes, yeah. You were not believing me in the beginning of the session that I was grabbing your leg by talking about the consultant, the contractor, and then I to many physics and many units and all the systems are explained, right?
Yeah.
I'm sorry for that.
No, it's fine.
But the course is very large, so we have to take a lot of information.
Yeah, I know.
So do you today make use of the session? Do you think it is?
See, I'm ready to receive information, and I don't care if it is a lot, and I believe I can take a lot of information. This is what I believe,
Okay, that's good. Do you understand today? Do you think that the session is useful to you?
Yeah. The end portion, the end part was relatable as well as was familiar with me,
Yes, the first part was a part of theoretical rather than practical issues, right?
Yeah. But it was also helpful because you see now I know what my function is.
Yes, how can we provide cooling?
Yeah.
So let's wrap up for you the two lectures. So do you see with me?
Yes.
We talked in the first part about the role of everyone inside the project.
Yeah.
We talk about the role of the owner. We talk about the role of the project management, right? We talk about the role of the consultant, the main contractor, and everyone like this. Okay? And we come to the conclusion that the consultant is the one that provides the design, and the contractor is the one that implements the design, right?
Yeah.
Okay. We said that what is the construction stages of any project? It begins with the feasibility study. Then the designer begins to design the building. Then it is put for tender or the bidding for the contractor, and the owner and the consultant receive technical and financial offers. Then the execution begins, and testing and commissioning is the last part before occupancy, right?
Yeah.
And the project ends. We talked about the several design stages, which begins with the concept design, where we provide only a report. We don't provide anything except a report. The report contains the codes that we use in the design, the input data we use for temperatures, lighting, and everything like this. We provide system capacity and the comparison, why to use a split unit, why to use air-cooled chiller, why to use water-cooled system. That is the main aim of the concept report. Hello?
Yes, yes, I'm with you.
Then we go through the schematic design, which is the phase of design where we provide ducts as a single line plans only. We don't provide much details in this phase. We should provide space requirements, where to put the chiller plant, where to put the mechanical rooms, where to put our units. Then comes the
Yeah.
stage of the design and the development, where we provide many details about the building, including chilled water, riser diagrams, and BQ. The last phase is the tender design, where we provide a complete package that will be used for construction drawings. In the second part of the lecture, we talk about the refrigeration cycle, which was the hardest part. We talked about how the air conditioning system provide cooling. We talk about that there are four main components that constitute the refrigeration cycle. The refrigeration cycle is a cycle that provides cooling. In the evaporator cycle, we use why it's called evaporator, because it absorbs heat from the space. Okay, this is the indoor unit. Are with me, right?
Yes, yes.
It extracts heat from the space. So if you heat a liquid, it will change into a vapor. How can a space with a 24 degrees Celsius heat the freon? Because the freon is colder. It is 2 degrees Celsius. So heat transfers from 24 to 2. This is normal. So liquid changes into vapor. So this vapor, we need to reject the heat that we took from the space to the outdoors. But you can see that this is a very cold liquid and the outdoor is at 46. So we have to pay money. We pay money by inserting power into circuit. The power is through the mechanical compressor. This is what we pay. This is what electricity costs us. So by inserting power, we change the vapor from the vapor state to hot vapor state. By inserting power into the system, this vapor state is 70 degrees Celsius. This 70 degrees Celsius can reject heat to the outdoors through a condenser by removing heat from the hot freon and releasing it to the hot air, which is at 46. Then it returns to liquid state. For compression cycle, we need to return the liquid to the cold state. This is the role of the expansion valve. Okay?
Yeah.
Okay, the condenser is the outdoor unit. Okay, so we discussed that the cooling load, which is results from people, lighting, ventilation, conduction, windows, anything, is called the Q evaporator.
Evaporator.
Yes. And we discussed the difference between the direct expansion system and the chilled water system. The direct expansion system, the evaporator, which is the freon, is cooling directly the air, which is called direct. Where the chilled water, the freon is cooling the water and the water is cooling the air, right?
Yeah.
Okay. The compressor power is what we pay for the refrigeration cycle to operate, right?
Yeah.
Heat released from the condenser is the amount of heat rejected to the atmosphere. We can cool the condenser by air, so it is called air-cooled condenser, or we can cool it by water, and it is called water-cooled condenser. We define a new term which is coefficient of performance. Coefficient of performance is what I get from the cycle, which is the Q evaporator, and what I give to the cycle, which is the compressor power. And from my benefit and economical point of view, I need a high COP. Why? Because if I increase the COP, I increase the gain from the cycle and decrease what I pay for the cycle. Okay? Okay?
Yes, sir.
Okay. We drive some equations which are not important in this stage. We determine what is the difference between enthalpy and how much energy is executed in each stage, and how to compute the coefficient of performance.
Yeah, okay.
In the third part, we discuss the different units. We discussed that the ton refrigerant is equal to 3.52 kilowatt, and the horsepower is equal to 2/3 ton,
Yeah.
which is the thermal units used in AC. In the last part, we classify air conditioning systems into two main types, DX systems and chilled water systems, and we identify the difference between them. We discussed
Yeah.
all the types of the split unit system. We discussed what is VRF. We discussed the
Yeah.
difference between HU and the fresh air handling unit.
Yeah.
We discussed what is meant by computer room air conditioning and rooftop packaged unit.
Mm.
By exploring the DX systems, we started with the simplest one, which is the window type, with a capacity up to 2 ton refrigerant. We said that this is very cheap. It has high vibrations. It has large noise. It has bad air distribution. We should cut through the wall to insert this equipment, right?
Yeah.
And it has limited capacity and limited lifetime, right?
Yeah.
Okay. We also examined some different parts or some different types of the DX systems, which are the ceiling split unit, the high wall, the cassette, and the freestanding.
Mm.
The split AC unit, high electrical consumption, low cost, limited time, capacity up to 5 ton only, and is mounted on the building facade, right?
Yeah.
Okay. Indoor units, it consists of high wall units, which is suitable for bedrooms,
Mm.
capacity up to 3 ton. We have built-in thermostat. This is the exposed type, and this is the concealed type. What is concealed? Concealed, it means it is invisible. People cannot see it.
Cannot say it. Yeah. People.
Because it is mounted through ducts and diffusers or air outlets. It has higher cost. Because higher capacity and can be used in living rooms, bedrooms, or offices. These are the shape of them above the ceiling. They need only 40 centimeters above the ceiling.
Mm.
Access hatch should be provided for maintenance, 60 by 60.
Mm.
It has the good architecture shape. We spoke about the cassette unit, which have many direction of the flow, two-way, three-way, or four-way. We discussed also the ceiling mounted units, the large one, which are exposed to people, which are mounted in pharmacies and shops. Lastly, we spoke about the floor standing rooms, which are they are existing prayer rooms and in offices. Then we discussed the PRF systems. We said that this system is very efficient because it can vary the amount of flow when it is connected to several systems. We can check one of them, we can shut all of them, we can operate all of them with no problem. It has intermediate cost, intermediate lifetime, and a high capacity, and requires minimum space because it requires only one outdoor unit. It can be
Yeah.
connected to 40 units based on the supplier.
Mm.
It has different operating strategy. It has one of acting compressor and one standby. If one fails, the other one would work. We said that the outdoor unit should be installed outdoors. If there is no option of installing it outdoors, it can be installed indoor inside the mechanical room, providing that you provide the ventilation for the room, for the unit, and you exhaust the air exhausted from it through outside the roof, right?
Yeah.
Okay, so we talk about the control unit, how to control between them, how to tie between them and BMS, and we talk about the connections, how to, this is the connections, while the branch and the header of the refrigerant between them.
Mm.
So that's for today. I need you to wrap up to study what we took today. We will have a quick wrap up in the next section. Okay. Next section we will talk about the HU units.
Okay.
How does air come from? How does, and we can start talking about the cooling load. How to compute the cooling load for any space.
Mm.
So after that we can take a large exercise on computing the cooling load, and we can discuss the software.
Okay.
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 So what are your impressions for this session?
So far, it's good because as far as I'm understanding, it's fine.
So you think it is useful?
Yes, of course. I think so.
Okay. So well, yeah, there are a lot of information. Should we decrease the information, or should we keep the same rate?
We'll decide in the process. See, I think so far the way it's going. Let's see. Let's see.
Mm.
Let's see.
You want to decrease the part of the process and increase the practical part, right?
Yeah, yeah, yeah.
Okay. 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 So do you have any questions today?
No, no questions for now.
Okay. So thank you. I hope that you get benefit today.
Yeah, thank you, thank you.
And let's meet on Sunday at the same time, inshallah.
Yeah. See
This
you
is
then.
an introductory session. After that, we will have assignments and something like that. So please don't get angry with me.
No, 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 no.
Okay?
Okay. Okay, thank you.
Thank you.
Thank you.
Bye. Assalamu alaikum.
So.